Hey, we're back. I'm Stan Stalnaker with Hub Culture. We're here at the Ice House in Davos. It's the first day of our programming and discussions here. Kicking off with the 1.5 degree imperative, a discussion about this target for climate change, the number we can't go above. And what 1.5 refers to is a 1 raise in sort of global mean temperature for the planet. And what does that mean? That basically means essentially what you might call global warming or the climate catastrophe or all these other things you hear about in the climate conversation. Kind of centers on this report from the UNFCCC, the UN like sort of climate body that looks at the consequences of climate change and the impacts of climate change and the likelihood of climate change. And the climate change is really driven a large part by temperature rise, not to mention habitat destruction and many other sort of components that actually impact our overall quality of life. So joining me now is Karl Burkart from One Earth, which is an organization that has been working on finding solutions to this problem. We just spent the last 3 moments with conversations looking at like the actual scale of what this means in terms of the 1.5 degree imperative, like why it's important for us not to go above that threshold target, what happens if we do go above it, and now we're going to shift a little bit more towards financing and solutions. So starting off with a roadmap for One Earth, how do we solve this problem, Karl?
Well, so there is a roadmap.
Is there?
I should probably.
Because I'm worried.
Yeah, no, I mean, after, when you talk to scientists, there is a lot to be, but the reality is 1.5C is achievable. And I remember you were talking about Copenhagen, I think I first met you, and then
I think we met in 09 in Copenhagen. We're old.
Rio plus 20, and like at the time, 1.5C was really so out there. Like everyone was like, only the hippies were like saying we need to do 1.5C, and then here we are a decade later, and everyone's like, we have to do it. So I was with Leonardo DiCaprio Foundation for many, many years. I started the science and technology program there, and we had this like existential question to answer, which is like, can we still do 1.5? Because we can't go out there and say, hey, let's do 1.5 if we don't have the science to back up that it's still feasible. So we realized—
Just because whether we can or we can't, we still have to, right? So otherwise,
the thing is,
we have to face reality.
Yes, but we were worried about strongly advocating for something that was no longer possible, which if you talk to a lot of experts, they'll tell you, 1.5 still. And so the thing is, we fortunately were in the position to fund, we met with over 100 scientists. We ended up funding about 30 scientists, some of the top IPCC authors, 17 lead climate and energy scientists, and we were able to fund them to collaborate on a new climate model, which really set out to answer that question, can we still do 1.5? Can we do it with known technologies? So that means not geoengineering, not that geoengineering might not come into play at a later point in the century, but we want to be able to do it now. So that was the challenge.
And how much better, if we can go, first of all, geoengineering feedback loops, right? So who knows the consequences, but
yes.
We can do it without geoengineering,
yes.
We can hit this target?
So it took about 2.5 years. We were very patient. Most of the scientists were German, so there was lots of translation required, and they ended up actually building a new model with a new budget, which is actually so carbon budget is a term that people will hear, which is actually like how much more carbon can we spend before we can't go any farther. And so this model, which was released actually at Davos, a little after Davos last year, showed that with a much more conservative budget even, which is going to be in the next AR6, the IPCC report, and factoring in biosphere feedbacks. So I wanted to say that because we were talking a lot about biosphere effects. Yeah. So they give a buffer.
So they've included the permafrost.
Yeah. Well, they've included a consensus position on a buffer, which is 100 billion tons of unknown possible emissions that nature might contribute as we warm to 1.5. So all of that was factored in the new model, and they showed that you can.
Okay, so what's the roadmap? What do we need to do to not go above this target?
Well, yeah, not surprisingly, energy transition is mostly what we have to do. And you hear targets like, well, we need to be 50% renewables by 2030. And they're we felt like those targets were not terribly meaningful, because what do they mean for a country or a region? Because Africa will be very different than Australia, than the United States. For example, Australia right now is living under 1.5C. Like, a lot of people don't understand 1.5 temperature rise. That means certain regions have already warmed to 1.5, like Australia is.
I mean, in parts of the northern and southern hemisphere at the extreme latitudes, not the Arctic, but that band just before, the temperature rises there have been as many as 2 or 3 degrees,
exactly.
right?
Yeah.
And we're talking Celsius, not Fahrenheit.
Yeah.
It's also one of those things, like Americans are like, oh, 1 degree, it's not that much. But how much is 1 degree?
Yeah, we're 1.1-ish right now. Yeah, I mean, 1.5 is going to be brutally ugly, but the thing is, if we can keep it to that point, as the previous speaker was just talking about, that is a hard limit where the threshold, the tipping points will likely get out of control above 1.5. So the climate model, you might have heard Greta say in her speech at the UN, she said, a 50% chance of 1.5 isn't good enough. And so we actually agree with that, and the model is modeling a good chance of 1.5C, which is technically greater than 66% chance. So it all can be done.
How much does it cost?
We need 1.1 trillion a year for the next 10 years invested in the energy infrastructure. Right now, we're getting about 300 billion a year. So we need another 800 billion a year for the energy piece. And then there's a nature piece, right? Because we have to protect our carbon sinks, our forests and our natural lands, so that they won't emit and they won't get converted and emit more emissions. And McKinsey has a figure for that one, which is an additional 300 billion. And then there's a restoration piece, which is in some ways the most important. So for me, the biggest aha about the climate model that these scientists produced was that the key solution is restoration. So, AKA drawdown. Scientists have been.
Is that planting trees?
Yeah, trees. So the scientists in this model took 4 that they could get good science at a global scale on. So that's reforestation, restoration, which is actually, I call it rewilding. So it's like introducing more biodiversity into existing forests. It's planting trees on croplands, which turned out to be a really big solution, and also forest management, so basically less cutting in managed forests. And those 4 allow you to get 400 billion tons out of the atmosphere of CO2.
So here's what stresses me out, right? So you just saw half of Australia burn, not half, but this radically huge amount. You're seeing it in Canada, you're seeing it in Sweden. So we're losing forest to fire that are, you think about like consumption and deforestation, right, being these terrible things where you're at least getting some human consumption out of, the material. But we're now just seeing like wholesale loss of massive things. So, how do you reckon that? Because we're losing way faster, not just from human use, we're just using it from accidents.
Yeah, well, I mean, it's a really good question. So the thing is that when nature burns, there is a restoration process that happens if loggers don't intervene. So there's an important forest management piece in letting the burned areas restore, and there's a lot of carbon that can get drawn down.
Because those trees are growing.
Yeah, well, and the carbon is basically, they get fertilized, and there's a natural cycle of fire, right? The Australian fire was really outrageous. It was above. Certainly, they have had big burns before historically, but it was a massive burn and devastating. Don't want to diminish fires in any way, but all the more reason to do the reforestation effort, because it's some way, that natural losses, which we were talking about, biosphere feedbacks, fire from forest fires is one of those. So that is factored in the climate model to do 1.5. So we still have to do the restoration.
But doesn't it seem like the natural losses are amplifying? Like, I just feel like even from when I was a kid to now, like my family lives in Oregon, and you used to go to Oregon and it was green and wet and like forests everywhere. And you go to Southern Oregon now and it's desertifying. like it's really scary. Like
Yeah,
there's areas that have been cut and logged, and they're not coming back.
the feedbacks are real, and they're happening faster than I think. Depending on the scientists you talk to, they're happening faster than they had predicted. And this next AR6, which is the Assessment Report 6, which is coming out for the IPCC, that will have. There's a lot of meetings going on about what is anticipated. But the thing is, like, to not go down the.
I do want to ask them what happens if we hit 500. I really die.
No, I mean, the thing is,
like,
we just can't. Like, I actually remember hearing a talk from an oil executive, a former oil executive, who said, we are going to do 1.5C because we have to. And so you kind of have to stay the course, and like you'll see this catastrophe here, that catastrophe there.
Yeah.
They are going to happen more, and they're going to be bigger, and they're going to be more frequent. But we still have to stay the course and be very clear about what we need to do to stay.
Well, that's why it's the imperative, right? Because I mean, we don't want to think about 500. I would love to know what that model looks like. But let's talk again about the solutions. So we know how much it costs. We know it's restoration. We know it's rewilding. We know it's protection of natural environments, and it's energy conversion. Those three things can get us there.
Yeah.
And so let's go back to the energy thing for a second. So spending that much for renewable, what percentage of, like, what does that look like in terms of the mix between, say, traditional hydrocarbons and renewable in the energy mix?
Yeah, no, so that is you asked the best questions. So that there's a paper that we also that's coming out in April, which is going to break down the specific contributions by sector, by region. Because part of what I was saying is like 50% by 2030, what does that mean? Well, each region has to have its own targets. And some sectors, like we look at four main sectors: power, heat, so building heat, transportation, and industry. Those are the four big ones. So transportation is what's sucking up all the oil. We're using all this oil, hydrocarbons, for transportation right now. There's a budget which we can keep doing that for a bit of time. What we have to do right now, which this report shows, is we have to rapidly invest in the power infrastructure. Because between EV and hydrogen, we're going to need a lot of power to be able to move vehicles without carbon.
So electrification is absolutely crucial.
That's the first thing. For example, the target that's coming out, it's not yet published, but it'll be in a few months, is the US. So we'll have targets. So like the US, for example, transportation, the power sector has to be 85% renewable by 2030. So this allows, right now I think it's 22%. So you're kind of like, we have to quadruple. And again, it sounds like
that sounds doable.
When I said 1.1 trillion, we've already got 300 billion a year happening. So it's 800 billion a year. That sounds like a lot.
3x better than we're doing now.
Well, and think about this, Stan. Like, the IMF just came out with their updated report on subsidies. They estimate 4.7 trillion a year is being spent by governments to prop up the fossil fuel industry and all of and consumption and all of the ripple effects of the fossil fuel industry. And so we're spending tons of money destroying the climate. So if you think and that's 4.7 trillion, we're talking about like 800 billion, so it's a small amount relative to what's being spent messing up our climate. So the money's there, right?
In the form of subsidies.
We just gotta move them. And I do
think we're also getting to a point where, like in solar, now, we have some friends coming later this week here to Davos who are in the solar industry in the US, and you cannot compete for a new build now against solar. Like, you can deliver solar in America for 7 cents a kilowatt hour compared to 15 cents for traditional. So, you cannot beat solar now, even without subsidies, which is amazing. So it's just a matter of scaling that introduction and then actually making money on it, because if you can scale it profitably, why not go make money doing clean energy?
Yeah, I put that question to a bunch of finance people, and I think one of the problems with solar is, like you said, it's actually lower than that now. The average bid price on solar PV utility scale is 4.5 cents a kilowatt hour.
And somebody just told me if they can get it down to 1 cent in Africa.
I think Facebook Live. I think it was in Abu Dhabi, or wasn't it Abu Dhabi?
Oh yeah, I think so. Said it in the Middle East.
That was a hybrid between two solar technologies, which is concentrating solar and PV. They hybridized that and were able to do 1.5 cent a kilowatt hour. So the good side about that is that no one should ever build another fossil fuel-based energy power plant because it's just insane.
But they're still building like 20 coal power plants in China.
Yeah, well, and China, we'll see what China does at the end of the year at the climate convention. But the reality is that because of it's so cheap, it's actually, you can't make big returns on it. You can, it's essentially financed by debt. So one of the things I'm really excited about this year, there's some really interesting progress on how to collateralize debt. So you remember the crash that happened that precipitated the crisis? Well, actually there was a really interesting idea in that crisis, which was collateralizing debt and making that a tradable commodity that then regular people and pensions could invest in. So there's a group in Cambridge that's looking at collateralizing debt to build solar. So use that idea for good instead of for evil. And that would allow money to just pour into renewables. So I think that economic or financial product is going to emerge in the next couple of years.
Well, I love that because that's going to segue to our next conversation from Hyperledger, where we could actually talk about some of the technology that can be used to get to non-linear solutions. I think that's, for me, one of the big lessons is that we can't go linear to get to 1.5. We have to go exponential, or we have to change the line of the curve. Like, we can't just go 1% better every year, or Bill says, we can't be a little less bad to be good. Like, we actually have to change course, and Google X, they look at moonshots, right? Like, we have to set our moonshot, and then we have to steer towards that moonshot, because we can't go linear and succeed. We have to have new technologies. Okay, so real quick recap on One Earth. What are you guys doing? Like, you're getting these reports out.
Yeah.
Go to OneEarth dot
One Earth,
something.
yeah, thanks for I always forget to plug oneearth.org. So the climate model, so the climate model book is 500 pages. I didn't know I was funding.
That's why you're here.
This is
I'm
what
not
happens
reading.
when you give climate scientists money to do what they want. They come up with a 500-page book. The book was put out by Springer Nature, which is one of the most prestigious science publishers, and it had 100,000 downloads, which is the biggest in their history. So it's being used by a lot of people. So our big theory of change, one of our parts of our theory of change is to really provide some of the unsexy stuff. Like, there's the sexy stuff that I love too, like Bill McDonough's the mulch layer, like, that's so cool. Or there's all kinds of cool, sexy stuff which we love too, but we also want to fund the unsexy stuff, which is just getting the science to decision makers. And so that's a big part of our work. Another part of our work is working with philanthropists. So we have actually a major announcement I thought we were going to be able to make today, but we're going to make it tomorrow.
Oh, come on, tell us.
I can't, no, sorry. But a funders coalition to really step up to the 1.5C challenge, which doesn't quite exist yet. There are foundations and philanthropists working on climate change, but no one's really set a bar for climate philanthropy for 1.5C. So that's what this new announcement's going to be about tomorrow. And I think that philanthropists, that's another big piece of what we're exploring is, the high net worth, ultra high net worth individuals. Credit Suisse just put out their report. People with above 50 million own about 32 trillion in assets. Just that money, a lot of those people they don't want a disaster, they don't want an apocalypse for their kids, right? No, the thing is, the money is just sitting there and on the sidelines. So it's like, how do we move the billions, trillions, especially over the next 5 years, which we think is this next really critical window. And I think that philanthropists, like seeing kind of like working with Leonardo for that time, seeing the role a philanthropist can have to play as an activist, and using their money not just to pay for things, but also to influence politics and influence decision making. That's a really exciting space for us that we're exploring.
Great, thank you, Karl Burkart from One Earth. Thank you very much.
Yeah, thank you.
Okay, we'll be back in a few minutes. We're going to talk about maybe dive a little bit more into the money and into the tech as we start to find our way towards something sustainable and solutions oriented as we co-create here in Davos at the Hub Culture Davos Pavilion. We'll be right back.